Hello students, we are going to conduct the lab 3 session. So it is based on the example number 5 from the lab 1. Okay, so we have already done the part design, right? So there are few modifications to be done to that, and after this workshop you'll have to practice this, right? So actually practice is the one that makes you familiar for the software, right? So and I'll be giving you along to do the workshop 1 and workshop 2, right? So I'll not be doing any guidance video for that. You all have to try it. It's simple, right? So we'll do the example number 5 here, right, starting from now. So these were a bit familiar for you as we did the design, right? There's a small modification for this, as there is a as you can see here, there is a thread here, right? So we can have this, right? And the stock is given here, right? We'll move on to the design. So students, the exercise number 5, right, from lab 1 is quite similar to the gear pump body from lab 3, right? So this is the gear pump body from lab 3. So we'll get the dimensions of the thread, right, across the mid, yes, this, right? So here we'll get the dimensions here, right? So you can see that the dimensions are 10, right, and 10 diameter of 10, and the height is from the top, it's 7.5, right? So we'll draw this, right? And there is one more measurement that needs to be done for right. Okay, right, so we'll exit this part, right? Okay, so we'll start with the part that we are designing. Right, I have tried it, but I'll do it again, right? So this is what we designed previously, right? So here, to get this part done, right, we have to have a, right, I'll delete this, right? Okay, so now to have this I need a reference plane on any side, right? So get a plane and then start designing, and before that you can get a midpoint line, right? we'll get a center line, and then start drawing this. R is 5, right? And then smart dimensions, 7.5 millimeter, right? Okay, it seems that it is too, now the with comparison to the previous part. Okay, so okay, I'll do the measurements here itself. No, not that. Figure this part, right? You can see this, the clearance over here is bit short, right? So right, so this point to here, it's 2.5, so that there is a small 0.5 clearance. Okay, so even though there's a clearance of 2.5 here, when we are going to what do you call, tap this, do tapping for this, the hole, right, or the groove, this, the clearance is not that enough, because like there's a slot going on at the top, right? So there will be some interruptions or some appearance here, like overcuts here, right? So that can be possible because of the drawing given specifications, right? We'll stick into that. Anyways, we'll get 8 here, right, in our drawing. Okay, so that this is for our reference, so we'll have that. I'll close this first, right? We'll have this as 8, either 8.5, yeah. Okay, 8.5 is okay, I guess, yeah. Right, so now the sketch is done, right? So going to Hole Wizard, alright, I couldn't show you that the tapping was in the size of M12 into 1.25, right? So you select NC metric and then straight tap. Okay, here it is M12, right, into 1.25. okay, and then here this would be through all, right? So the position, click on the part and then through all. Okay, so now it's done, right? You can hide on the plane and the sketches too, right? So the part is done now. So now it's a matter of machining this, right? So we'll save this part, right? So this is done. So now in the machining, before machining, right, I want to tell you that, like in previous machinings, it was a square, right? So in here, this is a cylinder, right? In such kind of cylinders, the stock, of course, we should separately design a stock, right? So here, a new part. And what is the stock dimensions? It's 80 diameter and 100 height, right? So front frame, so radius is 40, okay, and then extrude this to 100, right? You can measure this and see, right? Yes, this is okay, right? So we can save this as stock, cylinder stock, right? So this will be replacing as the stock, right? Now in previous, actually I mentioned it was the iron block that was used. In this, of course, this is a aluminium cylinder, right? It is stated here that it is an aluminium stock bar, right? So the stock bar is okay now. Now we have to the two parts here, right? So we have to make an assembly, right? So that is to define the stock, right? Right, so this is we'll set this as transparent, right? And now we have to seed this. You can make this, right? So it's made now, and you have to have this right into get into 40, all right, 50, right? Okay, so this side at the bottom it's 50 and the top it's 40, right? So now this is okay to go, right? We'll have this. Now we have this, right? The mating is done, right? In the solid cam part, right? First of all, we'll save this assembly, right? Okay, so we'll start the milling. Right, and the controller and the coordinating system. Click this side and then pick the origin to the center, right? Since it's a cylindrical, we should go with the center always, right? Center and the top level, okay? Top level of the part, right? And then okay, the axes are good now, right? So this is the temporary coordinate system, right? Now then you have to add the stock, right? For the stock, here you have to select as a 3D model, right? So once the 3D model is selected, you can click this, so it becomes pink color, the stock, right? So now the stock is defined, right? Okay, target is also set, right? So we can yes, we can go to the coordinate systems again, right? And then do a bit of editing to get this coordinate to the top level, right? Alright, you can pick the origin as this center, okay, and then to get the X onto your right side. So this is done, right? Now this is okay, all set, all the detailing is set, right? Okay, right? Now you can define the the operations, right? So first of all, facing, okay, face mill, right? The tool can be selected, can go with the face mill, right? 40, it's good. And then the levels, clearance level is there, the upper level is this, and the face depth is this, right? So you can you better set it to 10 by 10 step downs, right? 10 by 10 step downs, right? So you can select either anything. I'll go with the spiral, right? Okay, so we'll see how the machining will work, right? So it is solid verifying, so it will be like this, right? Okay, 1 2, then the third, right? So in the rest material, sorry, you can have this as the flow, right? Flow offset, and do the finishing. It's not showing. Anyways, right? So after the operation, it will be something like this, right? Okay, so that's fine. Now then the next components, right? So we can machine the profile, right? Now excess area, right? Alright, there is one more thing to do, right? In this face mailing, I hope that the rest material did not show due to this, right? We'll see whether this works. Right, so having that, we'll try this and see. Alright. Oh, why is this? Okay, anyways, we'll proceed with the operation, right? So next is a profile, right? And the profile, it's a new operation, so we have to assign the geometry, right? This is okay. The tool, you can select a new tool in mill, right? 6 would do the job actually, right? So we'll go with 6, and then the levels. now since this has been machined up to this, so the upper level will be that, and the profile depth will be here. Okay, so that's fine. And the geometry you can check whether it's machining outwards. Yes, it goes fine, right? It will bit increase the tool size to 16, right, to be on the safe side. Right, constant depth, rough and equal, step down. There's no need of a clear offset, right? So here it can be helical. Right, so that is also done. That is we had an equal step down and maximum step down 3, right? We can have it as 2. Right, you can either increase it if you feel it needs to be increased, right? Okay, now it's something's wrong with the rest material thing, right? So in the OSCAD you can see it is machined, right? So the remaining parts to be machined are the holes and the end, right? So that is fine, we can go with this. Okay, so we'll identify, now there is a pocket here, right? We'll operate right, since it's cutting the inside, right? So there's no need of having it to the left, right? Or if you need it to the left, you can have the operation part to left and then set the tool to the right side, right? So the tool here can be the same, right? We can use this same tool here for this operation. So the upper level is again this, because it is faced up to that point, and the pocket depth would be this, right? Have it to 5. Finish the wall as well as the floor, right? Number of 1 passes for the finishing. Alright, flow offset is not right. Alright, there's a small flash here. What is it? So there is a small remainder here, right? Yeah. There's a small remainder at the top. In the face mailing process, there's a small issue, right? Can have 50. Then we'll try this out. Okay, now I hope that's okay now, right? Yes, there's nothing to overlap now. Okay, so the pocketing is done, right? Now you can get the drilling done. Okay, and there's a slot to be cut, right? So we'll go for that slot operation with the dimensions, right? Yes, this is okay. I have to select the slotting tool, right? There's a slot mill, but here of course we can't use the slot mill since it needs certain diameter, right? So we'll go with the end mill here as well, right? So the end mill here, you can have it as 3 because the slot size is 3, right? Upper level is this, right? In the geometry you can see now it will cut with the middle feature, the feature here. So we have to prevent that. We'll select this to the left. So now it will be machining perfectly, right? So here these are okay, right? Here of course you have to wait, this should be the path should be aligned assigned from here. Okay, now it's okay, otherwise it he would not identify the depth, right? right? You can give the slot depth here, right? So we'll see whether it performs now. Yes, there's no issue in that. Right, so the slot is okay now. Right, now we'll do the first of all for these to have threaded threads, right, or threaded holes, will tapped holes, will have to spot drill it, right, even here, right? So we'll spot drill now, right? Operations, drilling, right? We can select the points directly, 1, 2, 3. Since it is the spot drill, it's just a small indentation that we have, right? So for the first layer, for one certain height, we can drill spot drill all the holes, right? Right, so we'll select a small tool, right? So the diameter of this small hole is around 3, right? It was around 3. Yes, so we'll use that size for the entire spot drilling, right? Select, drill, right? So now it's okay. By target, use a define. The upper level is this, right? And the drill depth is also this, right? Here we'll be giving the full diameter. Okay, so when we are giving the full diameter, it will go up to this extent, and the tip, only the tip would touch the, only the tip would do the indentation, right? Okay, we'll now see how it goes. Yes, right, so it is okay, seems okay, right? In the same way, we'll copy this and paste, copy and paste, and edit the levels, right? So it is the new geometry, this and this. Okay, so having those two, here of course since the size is bit different, R4 and R3, which means 8, 10, 6, right? So we'll use the 6, right? right? The sixth drill. And the levels, upper defined is this, and the drill depth is similar to that, right? And full diameter, right? So that is also done. See, right? Okay. Right now the spot drilling is done. Right now it's a matter of starting the drilling. Okay, so here there are tapered holes, right? 5 into 8 tapered hole, right? So we can do the drilling, right? Or we can go with thread milling, right? For thread milling to be done, actually, right, it will cut, right? We'll go to thread milling. So the thing, the holes that needs thread milling is this, and this, right? The other two are just drilled holes, right? So here it's okay. Select the tool. So when selecting the tool, it would be a thread mill, right? Choosing the standards as metric, ISO, and select the required size, right? So it's M5 into 0.8. okay, so this is okay, right? Can define this upper level and the thread depth. Now the thread depth is, how much is it? To set that, it is only 15. See, this hole is as well, this is 15 as well, and this is also 15 full thread, right? So this is 15, right? It's okay. Now in this threading, we have to cut this from top to bottom and not from bottom to top, right? So it will start cutting from top and goes to the bottom, right? So you have to select top to bottom, right? Right, so finishes one pass. So that is actually enough for the process. Right, you can see the actual size is this, right? Not this. Actual size is this, so it is perfectly doing its job, right? Also the second one, right? Likewise. Now it is done, right? So that is also okay, right? In the next we can copy this and paste again, right? Before that, we can drill the two small holes, right? So the diameter was 3, right? Yes, the diameter was 3. Right, so this the upper level is this, and the drill depth, of course, they have given it is up to 15 depth, right? So we can give yes, drill depth as 15, full diameter, right? Right, so that is also done, right? It is also done, is okay. So now we have the main 2 holes here to drill, right? So we'll copy paste this, copy and paste this, and edit it, right? This geometry as a spot, right? The tool would be, you can use same drill actually, right? So we can go to the drill number 6. Oh, yes. This is for, yeah, we cannot copy paste because it is a threaded drill, that threaded operation, right? So we have to omit this, right? So that was deleted because it is not a thread operation, right? It is a normal drilling operation, right? So we can actually copy the last one and then edit, right? Okay, so the tool here we can select as 6th, the next drill, right? The upper level is this, and the lower drill depth you can select it as this, okay? And the full diameter, okay? So this is fine. Right, yes, here since it's 2 different holes, right, with 2 different sizes, we have to get, yes, we have to get two drill operations here, right? The spotting we can have the same, but here, since it is yeah, two different sizes, right, we'll go with right. So we'll clear this. Yes, so this is the only one, right? And we can have a bit of depth again, right? We can have this to so sorry, -2, right? Or -1 is also okay, right? Just to make sure that the drilling is perfectly done to the right extent, right? Okay, now it seems okay, right? You can see here, right? So the other one is this. Yeah, you can copy paste this again, and then you can edit it, the geometry, same geometry. Oh, since it's a different operation with different tool, right? One is selected, and then the tool size is 8, right? So there's another new tool coming in, which is 8. Okay, so with that, and the levels are pretty much the same. Okay, all right. Yes, that is also done, right? You can see it is also done, right? So now this part is okay. Now we have to rotate this and machine the below part, right? So you can, yep, we'll have another face operation done, right? A coordinate system, add the coordinate system again, right? Pick face, pick take this, okay, pick the face and click this. I've selected the coordinate, right? And then pick origin to the middle, right, and flip it around. Simply the same procedure, right? Now the coordinating system is all set for the second process, right? Okay, now face mill, can define this, right? So you defined it, and then the tool, you can select the very same tool just used at the earliest operation, right? So the upper will be this, right, and the face depth would be this, and equal step down it would be 10 by 10, right? and here it would be 50% of the tool, right? And final finish, final one pass for the finish, right? This will go to contour, right? Same way, seems okay, right? Right, so it's fully clean now. Okay, we could have seen from the rest material, but it is not shown here, right? So now that is also done, right? So we only have the two, this and this hole, these two holes to be done, right? So we have to create another position. Right, now we are mounting this in sideways, right? We have to have another position, right, for the drilling. Coordinating system, can add this as the first plane, right? And you can take it to here, right? And flip this around, right? So this is okay. Now first of all, the spot part, right? You can drill it straight away, right? But since this is 80 millimeter, right, I don't think the drill would be that long to get penetrate the next very end, right? So we'll do it into two operations, right? So the tool, so the size is 10 millimeter, right? So first we need to get the spot drilling, right? For the spot drilling we'll have this, right? Anyways, it's a spot drill, just to make sure that there is no any other movements during drilling, right? So the upper level is this, right? And the drill depth, you can have it to this place. Oh sorry, this is the spot drill. So yeah, the lower level is the same as well, right? And you should select the full diameter, right? So the spot drilling will be done now, right? Okay, so that is fine. Same way, now we have to do the operation of thread cutting, right? So we cannot copy paste that, right? So we'll have to add a operation thread milling, right? So give the coordinate, and then select the tool, right? Now it was M12 into 1.25, right? thread mill, choose the standard metric, and then here there is no 12 into 1.25, right? So we'll go down further and 12 into 1.25 is found, right? So it's a fine thread, right? So the tool is tool diameter, yeah. So this is already preset, okay? So there's a preset in this. Once we have selected, there's nothing to be changed, right? Now the upper level you can give this, and the lower thread depth you can give this, right? So additional drill depth is given for additional, like, to make this in one operation, right, without any other additional operations, right? So straight away additional depth value must be positive, okay? Technology top to bottom, right? Okay, there it comes, right? Okay, so we can have this to 2, okay. Now it's clear, right? The same operation will be onto the next side as well, right? So this is okay. For the next side we have to align another coordinate system, right? Assign another coordinate system, drilling, coordinating system, add a coordinate system, right? Pick origin as this, because it should be, make sure it should be left side corner, right? Axis should be X to the right hand side and Y in front of you and Z towards the top of you, right? So that is right, the signing is done, right? The fourth position. Oops. Now the geometry, right? So you can select this, and what is the first one? It is a spot drilling, right? Same tools can be used. The upper level is this, as well as the lower level is this, full diameter. right? So we'll see whether it's yes, this spot drill is okay, right? So that part is fine. And the last operation before concluding is treadmilling, right? So the treadmilling coordinating system is 4, right? Select this, same tool, levels. The upper level is this, right, and the lower level is this, having a depth of external depth of 2, right, and it should be cut from top to bottom, so those are okay, right? Right, you can see it is cutting, right? So the machining is fully done, right? So you can calculate these all the operations here, calculate all, right? That's pretty much complicated, right? Anyways, so this is okay, right? You can then get the G code of all, right? Save it as a right. So this is done. So I hope you did gain the knowledge in machining such a advanced part, right? Looks bit advanced, but it's not that hard if you have the practice, right? So do the workshop 1 and workshop 2, as well as do practice this as well, because like you all have very limited time, right? You will be getting the assignment in 1 week or so, right? It would be 1 week, or we will see whether if we get any extensions we can have it a week after, right? Anyways, before the exams, right? Okay, right, thank you for joining. Join with the lab number 4, right?